So we have the different membranes. Don't forget to use the correct tape for the correct membrane. When it comes to membrane, there are many different things out there as well as membranes. There's also other products. There are some OSB boards and ply boards where actually coated with a airtight membrane. You can buy it and it's already got an airtight thing on it. And all you do is you tape over your nail holes when you fix it. It's actually a racking board with a paint on it, which will give you the airtightness. There's also liquid membranes. One is particularly passive purple. I've used the product many times. And we paint it or spray it onto a surface. It's particularly good for retrofits because it will spray or paint onto anything that's already there. So it's really good. So when it comes to the materials, research what it is you want to use for your product. There's plenty of people out there willing to help you and advise you on your materials. Pure House, we will help you with your materials. Talk to us and we will talk about materials, products, and how best to use them. A selection of a few tapes here. Again, there's only a few here, many more on the market. Because, again, when it comes to your membranes, you may have a different kind of tape to what we've got on here. Always research what your tape you need to put onto the membrane you've got. Because otherwise, you won't maximize the efficiency of the products to which you're using. And always follow the manufacturer's guide to how to use it, because these products are all very, very good, but some of them react a bit differently. Like, for example, this one here, the SIGA. That's an excellent tape. Works really, really well. Once it's on, you can't get it off until it gets hot. It's not good in a particularly really hot environment. A medium temperature or climate's good. It won't work in a very, very hot climate. Yeah, the TESCON will work in a very, very hot or very, very cold. So you may need to look at the different tapes for the different materials, but they are all very good for what they're designed to do. Safety when using a tape. This is something I always talk about because I've actually seen somebody decide to stick this on another person while they're asleep. And he ended up in A&E because they couldn't remove it without pulling his skin off. And there are other things as well. People use various different things and don't. The tapes that you use for your airtightness are designed for airtights. Use them for what they are designed for, because they are safe to use until somebody uses them what they're not supposed to be used for. The membrane. When it comes to the membranes itself, we follow some basic rules. Basically, many membranes, such as this one, this is the INTELLO. What it does, it actually gives you all the information you need. If we look here, we've got lines to the overlap. So when we come to the overlap, we know where to go to. We've got another line here, so we know where to tape to. Okay. The information you need is there. When it comes to cutting on a vertical line, we have increments of 100 mil, which is obviously mimicked on the other side of the tape. So therefore, you can always get a square cut. Comes in very, very helpful when you're trying to cut in situ, when you're trying to get an upright line or a square line cut. There's also other little things that we can do to try and help with the membranes to keep the airtightness, and that's how we fix it. How do we fix it? I use Clout nails. Clout nail is, I use 30mm Clouts. They're a typical galvanized nail, but with a wide head. But most people will recommend you use staples. Staples are good. They will hold it, but sometimes you want to pull the membrane to get it really quite taut and tight, and you get all those creases out. And sometimes they'll pull through. And every time they pull through, they're creating a hole that will need to be repaired. A piece of tape is all it takes, but it still needs to be repaired. With a Clout nail, you'll be able to pull on it more. It will take a lot more pressure before it pulls through. And you can sometimes get the membranes a lot tighter. Now, this works on all membranes that I've used. I also tried to get the fixings within the overlap. In this circumstance, I've actually put it within the tape line, because regardless of how it's going to be used, those nails or those fixings will be covered by another piece of material, whether it's an INTELLO or whether it's the tape. So it's instantly airtighted over those anyway, because of where we put them. So placement of fixings can be quite important. So once we've got the INTELLO on, or we've got our airtightness barriers on, we have to look at penetrations. What do we term as a penetration? Anything and everything that goes through the envelope wall. Whether it's cables, piping, could be anything, any service at all, has to be airtighted. So how do we do this? There's many different methods. The best thing, if you've got a standard way of working or a standard pipe, we use rubber grommets or gaskets that come with the holes cut into a particular size, and we push those over and we tape around the outside to make sure they're really airtight. This works nicely on ducting, pipes, even cables. If we have lots of cables coming in through one area, doesn't happen often, but we do have it, that we can just punch a very small hole, force the cable through, and each one of those will be airtight. But do note that all the cables are separate. Whenever you're trying to airtight, whether it's pipes, cables, or whatever comes into a building, is always going to be separated, because otherwise, if you bunch them together, you just got tubes of air. These cables are all together, just forms like tubes of straws, a bunch of them, and the air will travel through that at a great rate of knots. The same with anything that's round especially. So separate, then you'll get your air tightness. That's rubber grommets. We also have top hats. Top hats are self-explanatory. They look like the top hat. Now you can buy these in many different sizes and shapes and angles, whether it's round for a standard, a square for a post or something similar, or angled for a roof. Okay, there's only one problem with all that we've spoken about at the moment, is they're designed for standard pipes. My first job, we had 325mm pipe. But at the time, there was nothing that we could buy to go around that, so we had to make them. So I took the top hat design and I made top hats. And we made these top hats and we put them around, and we had a really good success rate. And I followed this method and I've not had a fail on one yet. So follow the rules and you will do really well. We get some really good air results. So these are pre-made top hats, and they're really good, especially when it comes to standard pipe work. If you've got a collar on your pipe work, or you've got a non-standard size pipe, we can't buy one of these. We cannot buy one to fit it. So we have to have a look at how we can airtight that. Sometimes non-standard penetrations. This is what I always call this, non-standard penetrations. And the reason is because the process has to be followed the same as when we were using the rubber grommets. We had the cables coming through and we separated them and brought them all through so that every single cable that came in had its own airtightness around it to make sure it was 100% airtight, or certainly as airtight as we could get it. These are 100mm rigid coil ducts, which came through the base of property that we did. And again, we've separated them, and so we could get the air tightness in between. I call that non-standard penetrations. In other words, there's multi-penetrations. And always separate. non-standard pipes. This is another couple of examples. MVHR ducting. These are a semi-rigid duct. They're actually in aluminium. They're actually very delicate, but we still need to hold the shape because there's another tube sliding aside there to seal. So we had to make something to go around it. We had to use a thicker material because we had to hold the weight of it as well. So how do we make a top hat? Basically, we get whatever tube. If you've got an offcut, it's a really good thing to do, is to be able to use that to mark and make stuff. So I've got a flat piece of airtight membrane there, and I've cut it big enough so that the pipe will sit in and give me clearance all round. Then I've used the pipe and I've made a tube of INTELLO. Well, my airtight is just wrapped around, good air tightness, sealed on that, so we know it's got a really good hold. You can make these as long as you like. So if you've got 2, 3, 4 foot pipe, why not make a tube that length? And then you cut it down into multiple bits, and then you've only got to do it once and just cut it to length, or the desired length that you need. Once we've cut our tubes, I'll squash them flat. I use a little straight edge or a piece of timber, and I cut lots of fins, about 20 millimeters in, because what that does is that fans the mat when we maneuver it into where we need it to be, and we can use that for taping onto. Here you can see the fins and how we spread them out. Then we take our piece of membrane that we cut earlier and we slide that over the top, and that forms our shape, that forms our top. But what we've got is this joint here is not slipping and falling apart because we've done those fins that spread out, and when we put this in, it's got something to sit on. Then we tape the outside. Now I've got the piece of pipe actually in here, the piece we used to cut the hole and make the tube. When you make the tube, do not make it tight. When you cut the hole, give it 2-3 mil all the way around, because that allows for taping and a bit of movement. And the same as when I make the tube that goes around the pipe, I also give it a little bit of looseness, a little bit of slack, so it slides around easily as she moves around on the pipe. Just makes things a lot easier. So then we seal around the outside. We do that with very small bits of tape, 3 inches long, 70 mil, and I put them in layers. Stand them up, squash it down, stand up, squash it down. Make sure it's really tight into this corner. And I do it in short junctions. And then a piece of tape all the way around, and that brings it all together. Once we've done the other side, I turn it over. Once we turn it over, we then use other short bits of tape and we stick all the fins down the other side. So we've actually got 2 ways of airtightness. We're sticking around the back to prevent air, and also we're stuck on the front to create airtightness there. So we're double packing it, we're double taping it, and we get some really good results. Okay, process of making the top hat. Very, very similar. Very, very simple. We mark around pipes and we allow 2-3 millimeters all round. Do not cut it tight. Use the pipe to make the correct membrane slightly loose around the pipe. Using a straight edge, cut slots 15-20 mil and 10-20 mil apart with the standing knife from a straight edge. Slide the membrane over the hole and the fins. You see how it's spread out. Using the correct tape. Always, again, use the correct tapes for the correct membrane. For the membrane, use the correct tapes. Once the outside is done, flip it over, do the other side. That way you've got 2 layers of tape, 2 forms of barrier of to prevent loss of air. Sorry. So we have 2 layers of tape, one each side, and that way we can really control the air tightness around that pipe, and you will not get a fail if it's done correctly.
John, on this slide, it mentions 10 meters cubed, meters squared.
10 cubic meters.
10 cubic meters. And just to be clear, so that basically correlates with the building regulation standards.
Yes.
Yeah. And so the 0.6 meters cubed is the passive house standards.
Yes.
Yeah, I just wanted to
Yes, this is what we strive for. You can get, if you get below 1, it's amazing. If you get to 0.6, that is the passive house requirements to passive house standards. And you can achieve it. All you need to do is follow the rules. We very rarely fail to achieve it. The few times we've not achieved it, it's because we've forgotten to cover an end of a pipe. We've done the air tightness around the penetration, but we haven't actually covered the end of the pipe, which we have to do on an air test. Or there's a trap and a sink that's not been filled full of water. So it's an air.
So there's a real skill to actually, do an accurate air test.
To do an accurate air test, absolutely. It's just remembering to cover the areas which you need to cover. If there is a pipe penetration or something like that, it will need to be taped over or capped off before you do the air tightness, because it won't be part of the air tightness. It's how you seal around that pipe that's part of the air tightness.
Got you. We've talked about the 0.6 stand for passive house there, and there is also what they call the Retrofit standard, which is 1 meters cubed, and then they've talked about the AECB standard, which is 2 meters cubed.
Yes, yeah, there are a number of different standards. Sometimes you need to just get one and below. When it comes to retrofit as well, we have to look at air tightness for retrofits, because you've got an existing product. You may not be able to get anywhere near or to this with an existing product, because there's only so much you can do with an existing construction, because all those joints are already there. You can't design it to be airtight. You can't put in a design to compensate for that. So you have to do it with the air tightness. So there has to be some versatility or flexibility in these figures, depending on the project, but it has to be job specific, project specific.
Yeah, and we've talked about the cost-benefit ratio.
Yeah,
I think is really important, especially when it comes to retrofit.
Right.
So I know that one of the standards is 5 air changes per hour. So we are pro being flexible.
Yeah, we've 5 changes, 5 and 3 at the moment is going to be standard. If it's not standard already, it's going to be the standard, which is better, but lower the better. For a existing build, we're going to do a retrofit. I think a good way to look at it, we want to be about 3. Anything below that is excellent. 3 is actually very, very good.
Yeah. So maybe some revisals on the existing standards that are out there. I think quality assurance is a really big piece to this being effective.
Yeah. Quality is always key to anything, regardless of what you do. Whether it's air tightness, it's insulation, it's airflow, it's anything. The standard we need to require to reach is correction. The standard that we need to reach can only be reached with a little bit of attention to detail and thought of the process. We can do it every time, but we just have to approach it in a considerate weight of what we need to do to achieve the required standard, and that's attention to detail.
Excellent. I'll just come back to this image. Yeah. So we're talking about some of the challenges with the retrofit in terms of air tightness. And one of the challenges that I'm thinking about from my own personal experience is I've got a suspended timber floor. And it took me, when you first came into my house, you were like, Kev, you're losing a lot of air through your floor. So you were able to spot that pretty quickly. And then obviously there's your personal circumstance, which is a bit different because you've got a bit of a heat sink in terms of your foundations. So it's not air tightness, but it's just demonstrating a difference. And maybe you just want to just touch on those things.
Yeah, the different types of air tightness when it comes to a retrofit. Yes, you get suspended timber floors. When you get suspended timber floor, sometimes you need to take the floor up so you can layer a membrane up and over in between the joists, and then you can lay an insulation in. This isn't always possible to take the floor up. So if you can do it from underneath. If you have a crawling space or an area where you can get a spray in, there are some spray insulations. Or in my circumstance, I have a concrete floor, but it's actually a raft. So the concrete floor is actually directly onto the ground. So the whole ground floor is basically a cold bridge. Heats out of my house. Doesn't matter how much heat or how warm the house is, feet are always going to be cold because it sucks the heat out. So we need to look at that and study the insulations which we may be able to use to combat that. And this is why when it comes to retrofit, you really need to look into the products to which you can use. If you can raise the door heads easy enough, put in a really good insulation. If you can't, look at the best you can do with what you've got. Because sometimes you are restricted to what you can do because you can put lots and lots of money in it and get no benefit. So you need to look and study and see what you can do, the best you can do with your existing build.